Good day, and welcome to our webinar on machine safety and security, brought to you by CFE Media and Technology and sponsored by Gorbel. Joining us today will be Sean Daswani, Senior Electrical Engineer and Machine Safety Business Leader, Polytron, and Gregory Hale, Editor and Founder, Industrial Safety and Security Source. I'm Kevin Parker, Editor of Plant Engineering Magazine. Machine safety, like so many other engineering disciplines, is changing rapidly in the light of emerging technologies. In this webinar, we'll examine two key aspects of machine safety. First, we'll look at the latest developments bearing on machine safety verification and validation as a means to smooth transitions from design to system implementations. In an additional presentation, we'll discuss how, given machine interconnectivity, cybersecurity has become a real safety concern. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. To take the Learning Unit exam, use the Learning Unit Exam tab option at the top of your screen. The exam will open in a separate browser window. You can complete the exam after the webcast. However, the link will break when the webcast signs off. The exam will be posted on CFE Media websites with the on-demand version of this webcast. The exam is for one RCEP ACEC Certified Professional Development Hours. To get the best results from the webcast platform, please make note of the following. For technical problems, click on the question mark at the top right-hand corner of the screen to bring up a list of system checks to make before escalating to an online technician. If you do experience issues with the slides or audio, please refresh the browser or click the Refresh Media button directly under the presenter's headshot. Volume settings can be controlled by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If a technician is needed, type a message into the Ask a Question box, and someone will get to you as quickly as possible. Answers to technical questions will be in the Answered Questions box on the left-hand side of the screen. The Ask a Question box is also used to ask the speakers questions. Ask questions at any time during the presentation. We'll get to as many as time allows. To download the presentation slides and certificate of completion, use the Event Resources box on the left-hand side of the screen. You can download the presentation and certificate of completion until the conclusion of the webcast. The link will break when the webcast signs off. This webcast is being recorded, including the Q&A session. We'll send you an email message within a week with a direct link to the webcast archive. We'll now hear from the sponsor of today's webinar. At the end of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Stay tuned for today's presentation and discussion.
Protect your people, profits, and productivity with engineered and mobile fall protection solutions from Gorbel that are a class above. Gorbel's TetherTrack fall protection systems provide reliable and cost-effective overhead fall protection and reduce the risk of injury in elevated work environments. Choose between our ceiling-mounted systems or our freestanding systems to find the solution that's right for your facility. Gorbel's Ranger Mobile Anchor is the portable fall arrest system you've been looking for. This towable fall protection anchor is ideal for maintaining and repairing aircraft, industrial equipment, or heavy machinery, or for any elevated application that demands mobility. By matching the right system to your exact job requirements, we offer superior safety while keeping productivity at essential levels. Whether the job requires protection throughout the day or just sporadically, Gorbel offers a full line of TetherTrack fall arrest solutions that you and your workers will embrace. Speak with your Gorbel dealer to learn more about our full line of fall arrest solutions.
Welcome back. I'd now like to introduce our first speaker. Sean Daswani is a professional engineer with more than 16 years experience in industry. As the machine safety business leader at Polytron, Daswani manages a team of engineers involved in all parts of machine safety lifecycle, including risk assessments, safety design, implementation, and validation. He possesses a wide range of knowledge of control systems and has led Polytron's programming standards team responsible for developing standards for the changing controls environment. He has served as a project leader and project manager and consulted on complex systems designs and implementations. Daswani is an electrical engineering graduate from Georgia Tech and certified functional safety engineer from TÜV Rheinland. He is a published author and presenter on safety-related topics. Sean, welcome to today's webinar, and please go ahead.
Thank you, Kevin. Thank you, guys, for joining us today. And I'd like to tell you, so again, my name is Sean. I'm with a company called Polytron here in Atlanta, Georgia. We've been in business for over 35 years now, doing innovative solutions for manufacturers in all aspects of automation, safety, machine intelligence, cybersecurity, everything what we say in the four walls of a manufacturing facility. We have about 50 engineers, which about 10% of those are TÜV certified safety engineers. So thanks for having me today, and I'd like to get started now with talking about, give you a bit of a case study on what I consider an aspect or a couple of aspects of this safety roadmap or safety life cycle that we all kind of work in, or some of us work in, that sometimes gets overlooked or gets not enough attention to or done improperly. I've seen it through a lot of my work experience here at Polytron, and so I want to give you a case study of what I've gone through and what we've encountered and how we've gone through that process to make sure we're doing those things properly. So showing here is a safety life cycle. We've probably all seen this before or used this before. In my type of work, in my business here in safety and Polytron, that we use this almost every day to understand what piece and part of this life cycle we're at in a project, how we're working with customers to get to the right safety machine state in this cycle. And you know, it all starts with that risk assessment that gives us those details of the hazards identified, what the risk rating of those hazards are, be able to come up and give recommendations for the safeguards to mitigate those risks. Because in the end, that's the goal of all of what we're trying to do here, is mitigate the risk, as OSHA says, to provide a safe work environment. So in machine safety, that's what we're here trying to do, and it starts off with that risk assessment. So taking that risk assessment and providing functional requirements that give us a more detailed scope of what that risk assessment recommendations came up with, to detail those out in what we call safety functions to mitigate all those risks or hazards that were identified. And taking that functional requirement and putting it into a designing that those safety functions to do either guarding, or designing out, putting guarding or using safe technologies to mitigate that risk. Taking that design, then installing it, and then, as we see here in this life cycle, maintaining and improving it. Anytime there's a change or upgrade, that we need to go back and reassess it, relook at it. Is there more additional hazards that have been involved, or has it changed now the functionality or the safety functions in which we need to go back and look at how that's being affected? So you might see here a couple of items that might be missing, which I'd like to talk about today. And those two are very critical, like I said before, in this process. And sometimes, like I said, it gets overlooked, done wrong, or done improperly. And the first one that I want to talk about is, let me step back a little bit and talk about and get into the case study and kind of kind of give you a picture of how it gets started and what kind of frame we're in. So in this case study that I'm talking about here, we have a new line, a new production line that a client of ours is putting in. Their main focus now is to have a new product out on this line in a scheduled time, and they have multiple vendors that they're trying to get in line, provide these equipment, to provide it in the timeline that they want, in the production and speed they need to hit the production rates, and to be able to get what they're looking after. Now, a lot of times when this process is occurring, safety is an afterthought. It's not looked at in this beginning stages when these manufacturers are trying to bring all this equipment in and try to get these things set up. But here in this study or this example, our client chose us, came to Polytron to come and be that third-party objective view that focuses on safety, and then ask these questions, ask these couple of or few questions as this project is going on or getting started. Are the client's safety standards being applied from the vendors that are providing all the equipment? Are just overall machine safety standards, ISO, ANSI, OSHA, are they being met by these vendors? And are they using standard hardware across our platform that we have already spec'd and we want to stay consistent in our facility? And are they providing the proper documentation? So we're in this in this role as providing a overview and overlook to these vendors to assure they're providing what the client is or the customer is trying to get in the end on safety, because again, there's lots of other factors that are trying to get this line in, and we don't want safety to be overlooked. Now, again, like to say or mention here that this customer or this manufacturer, they have a maturity level in the culture of safety that's very high. So they understand already that safety is very important and needs to be addressed throughout this project. And where some cases that's not the case, and and it needs to be addressed. And you hope these manufacturers are being proactive and having that culture of safety ahead of time. So as we're asking these questions, we're getting into that first piece of that safety life cycle that I was talking about earlier that was shown kind of missing, and that's verification. So when I talk about verification, I'm talking about verifying before implementation, before the machine's on the floor. We're starting this on the onset of the design, or even before that, in the risk assessment. Maybe the vendor is not as up to par on safety, and they need that additional help on safety risk assessments or developing safety functions. The primary portion of this verification happens at that design phase, where this risk assessment's been done, it's been identified as the hazards, requirements for those safety functions or guarding has been identified, and now we've been designing it, but we're acting as that third-party validator and verification. We are working with the vendor, with that OEM manufacturer, who's providing this equipment. That are those questions that I had earlier being fulfilled? Are the company standards being met? So on that note, we see, in what I see a lot of in the industry and manufacturers, is that manufacturers, large manufacturers, will typically have their own safety standards, and will already have a blanket statement of everything needs to be Cat 3, PL level D, C, E, something. No matter what the hazard is, well, again, at a minimum, no matter what the hazard is, or how low or medium risk that hazard may be, always provide a blanket minimum category of Cat 3, PL level, C, D, or E. In this case, we had a manufacturer that is wanting a Category 3 performance level C as a minimum. So our goal here is we know that information. That information is being sent to these vendors, but vendors, or I say OEMs, already have certain design packages for machinery that they're already putting out. They're building multiples of these machines, and it sometimes get overlooked at these safety standards that a company might have that they want to make sure that are being met. So, how do we make sure those are, are coming together? And that's where that verification process of a third party might come in this case, Polytron, to do this verification to understand that the products and the hardware that are being implemented are set properly in the architecture that's required, Cat 3, not Cat 2 or Cat 1, to fulfill that first part of that requirement. So you'd be amazed to see, from what I see sometimes from these OEMs that will provide us drawings. Again, we're requesting drawings, we're requesting all the information that they're putting together so we can review over safety. And we see some of the things like this, and that they are claiming that is, Cat 3 or control reliable, and of course that's not the case. And so our purpose here is not to point fingers and say this is wrong, tell the manufacturers purchasing this equipment, hey, these OEMs don't know what they're doing. I don't know what they're doing. It's our job and our kind of duty here to guide them, right? Guide them to understand what those safety requirements are, what's required for the manufacturer to meet the design criteria for safety, and how to go about doing that. And so we take that, take the initiative to help them formulate their safety functions that they believe is correct, but show them how to do it properly to get something in the form of a true Category 3 safety function, something like this, and where we do have a set control reliable dual channel inputs to a control reliable safety logic unit to a dual channel with control reliable monitored output with feedback. So that part is a critical piece, again, up front, getting that information from the OEM to work with them. In some cases, some OEMs do, dive very little into safety. Some do not, or some do and know a little bit more about safety. And so we try to get everybody on the same plane. So we've got our architecture, from EN 954-1, where our categories came in. We've shifted over time into a more analytical and statistical view of safety, and where we get our performance level in ISO 13849-1, and which allows us to get more detail, or I guess in the big data world of everything, of understanding all the components, statistical analysis of those components, safety components, to be able to determine the performance level. So now with ISO 13849-1, we need to understand what those performance levels are. And so in this case study, we had the manufacturer had a blanket statement of performance level required as C, where a risk assessment might have, performance level required as B, but we have to maintain a minimum of C. Now again, there might be other hazards that might require D or E, and so to verify those in this process, it's a critical point here to also have the documentation or use a tool to verify that performance level is being met, not just the category. So we have tools such as Systema, and we use Systema a lot here to go through and build our safety functions, to lay them all out. And it's a great tool because all the vendors that provide hardware, safety relays, e-stops, guard door locking switches, and so forth, they provide all this information in Systema files on their website that can be downloaded, integrated into Systema, and pulled out to assess these performance level safety functions. It's a free software, and we use that a lot all the time. But there's many more other vendors do provide other software packages, but it's another criteria in verification process. So as we're going through the safety life cycle, and one of the questions that we had up previous slides, is that right documentation being provided. So the vendors or OEMs, are required in safety standards these days now to provide or at least do a risk assessment and provide that documentation. So we find it hard sometimes that OEMs don't want to provide that, but again, providing that documentation is critical to the whole life cycle of this process. And so in that verification of this, we're looking for all that documentation. We're identifying all the safety functions and verifying that they're meeting the category properly, they're meeting the performance level properly. And like I said before, we're not trying to fail or show that these OEMs are not knowing what they're doing. We're trying to get to a passing grade of the safety design before that machine gets delivered. And we will go back through iterations and go back through circuitry, go back through guarding to verify and to get to a passing grade, knowing that having this done up front and before this machine gets shipped out, that we're going to be saving so much time, so much money if these items were not identified earlier or now in this design phase. So it is not for a third-party validator to come in and to just fail everything and say this is not wrong. It's a third-party verification validator to come in and to help get to the safety standards that's required for that machine that's being delivered. So I spent a lot of time on that verification step, and it's a very important step that I see gets missed a lot, that gets overlooked. And so when that's done properly, when we get to implementation, and get past implementation, we have a better and more clear vision of what the safety of this machine is going to look like and how it's going to function, and that little bit better security or knowing that we're doing the right thing. But just doing the verification does not mean we have a safety machine. We get to the next critical point, that's validation. And validation is documented in our standards, ISO 13849-2. That's been developed in association with the -1 version to give us the details on how to validate a machine properly. As being in safety and providing manufacturers with safety services, we always try to emphasize that the machine can't be considered safe without a validation being occurred, either by the end user or a validator like ourselves or someone else. But having that validator also a criteria of being not involved in that whole project, not design the machine, not install the machine, but has an objective viewpoint into how properly to go about this validation and using a set plan. And so there's lots of details and lots of other things that go into validation. Again, I'm keeping high level here, but just trying to outline the importance of that validation, because we verified it, we know the design is right, we know the performance levels and categories are met right, but how do we know that it's going to be functioning right? We've got them installed now, we've put e-stops in, we put safety logic relays in, we put contactors in, we've wired them for the design, but how do we know it's actually working? And that's where validation becomes a critical step. We have that plan that goes through, tells whoever that's a part of this process how we're going to go about validating, and that starts with normal validation, and that kind of occurs in kind of all aspects of any kind of machine, just normally checking the I/O, checking the e-stops, checking door switches opening, closing, and shutting down properly. And again, going back and revisiting the safety function requirements to say that when this e-stop hits, this is supposed to happen, and we're checking those off. So we have forms and documentation that goes through those details. So we're injecting fault here, right? We've probably heard of that term before. We're injecting faults into the system and taking that data out to determine, is that safety function that's supposed to be providing safety toward the hazard that's been identified properly. That goes for guarding as well. Guarding is designed on these machines to safeguard people from going into it, around it, underneath it, over above it, and we want to make sure that those items are always being taken care of. Are those guards being installed? Are they causing more hazards? And we need to identify those and validate those. So there's a validation piece that also goes with guarding, as well as programming. So a lot of items today now, as technologies have increased and more modular and more interconnected, and Internet of Things, of everything is IoT in certain ways, even safety, we come to more programming items and safety PLCs that are out there that are have to be validated as well, because inside the program itself, it's a Category 3 performance level structure that's being built logically in a ladder logic or function block diagram that has to be validated and checked and also documented. Sometimes this can be hard depending on the level or the programming structure that an OEM might be providing. They might not, a lot of the times that we find out that they do not want to give over that program or give the code because it's proprietary and understandable. So we have to do some other steps and be able to make sure we do either work with that programmer or do other steps to get that function validated. And again, with the process of verification, validation is the same thing. It's not just identifying something that's wrong and saying that's failed and move on. Hey, these guys don't know what they're doing. Everything's wrong. But it's working through iterations to get that corrected. If we do find an issue, we've injected a fault into a supposedly control-liable system, and now it's not functioning as we thought. We fail it. We document that it failed at this time, but we made a recommendation on how to fix it. We fix it, or help fix it, or give recommendations to fix it, and then revalidate it and have a clean sheet document that tells us that everything's been validated and everything is good to go. We've passed the machine and it's viable for production. So spent some time here talking about those two items, and again, high level, I went through here with this kind of case study that we do a lot of nowadays, where we work with our manufacturers to provide that third-party objective view into safety, to know that OEMs and other providers of machinery that are going on a plant floor are meeting the requirements. And some of those importances of being done on the onset. Again, I've been in a lot of situations where the verification process is being done by the OEM itself, assume that it's all good until it gets to the plant floor, and then we find out, hey, there's lots of things missed, and it's a mess, and it becomes more costly. Time schedules don't match up anymore, and it can really cause a lot of headache. And so, in that verification phase, doing steps throughout the process. Design isn't happening in one step. It's a iterative steps that go over time, and we try to check those at 30, 60, 90% of in the development of that design. And then use the tools. There's tools out there going through safety, getting TUV certified. You do have to go through calculations, and you can do those calculations if you would like, but we have the tools, great tools and programs that help us get that done a lot quicker. And so, creating the verification documentation that goes along with that machine, and also validation before I advise our manufacturers to say that that machine is good to go. A validation's got to be performed, documented, and passed and signed off by a preferably third party or someone not associated with the full design of that project. And what we like to inject with these validations, and even through the design, is people that are what we call owners of this machine in the long run, maintenance of a facility, operations, get engineers in the facility to be hands-on with this process, so everybody has some kind of buy-in in this and understands what's going on and how the process flows. So when we get back to that safety life cycle and we're doing the maintain portion of it, we've made a change. Hey, we know, and now the owners have the tools to go about and doing that on their own. So that's what I wanted to go through today. That's what my wanted to bring, which I think is important. So right now I'm going to give it back to Kevin and get on with the other presentation.
Well, thanks, Sean. It's much appreciated. I'm sure we'll have some questions for you in our upcoming Q&A, but for the moment, let's turn to our second speaker and panelist, Gregory Hale. Gregory is editor and founder of Industrial Safety and Security Source, a web-based information provider devoted solely to keeping manufacturers current on safety, cyber, and physical security news, products, features, applications, and trends. He has been in the publishing industry for more than 30 years, covering manufacturing automation for 10 years as chief editor of InTech magazine. Prior to starting at InTech in 1999, Hale was the editor-in-chief at Post Newsweek's Reseller Management magazine. In addition, he is the co-author of the book, Automation Made Easy, Everything You Wanted to Know About Automation and Need to Ask. Gregory, welcome to today's webinar, and please go ahead.
All right, thank you, Kevin, and thanks for allowing me to join in on today's webcast. I'm going to start off by talking about safety and security professionals are some of the most dedicated and passionate workers in the world. Their mindset is truly, nothing is going to happen to us today, not on my watch. And the feeling had always been safety systems are immune to cyber issues. Install the system, test it, maintain it, and it'll take care of everything. But not anymore. While this was a process safety incident, the safety world took a big hit back in 2017 when the Triton incident proved safety systems are not immune to cyber attacks. As a matter of fact, from an attacker's perspective, if I want to hurt a company, why not go after the safety system? For those that aren't aware of the Triton or Trisis or Hatman incident, depending on what name you want to go by, in a nutshell, attackers were able to get into a control system of a Saudi Arabian refinery, and they proceeded to take over a control system and the safety system. The bad guys owned both of those systems, and the attackers who were on the system for at least a year ahead of time made one mistake one day, and it ended up triggering the safety system, which then shut down the facility. The safety system did what it was supposed to do, but while you don't know what they were going after, the thinking is they were planning on some kind of destruction. Now that was a huge facility targeted by attackers to cause a safety incident. However, in today's connected and interconnected IIoT-enriched environment, that incident introduced a new level of concern for safety professionals. And that's just one of the reasons why the global security market is expected to grow to about $100 billion or more next year. The benefits of security are as they're out there. I have them bulleted here. But in many cases, the same benefits apply to safety, especially the top three. If you're applying security properly or safety properly, there's an increase in uptime. Obviously, the process will be uninterrupted, and there's a hike in productivity and profitability. But safety is all about keeping people, machines, the plant, and the facility and the surrounding environment safe. There's no doubt about it. But it's also a business enabler. If a manufacturer is applying safety principles and discipline in the proper fashion, it will not only keep workers and the plant safe, it will reduce unplanned downtime, which I discussed before, which increases production, which means more product can end up produced, which can add to profitability. This study by the Aberdeen Group just shows how top-tier safety providers are able to keep workers safe and keep them keep systems up and running. What's interesting, I find the most interesting about this is the 2% of unscheduled asset downtime for a top tier safety provider versus a 14% of downtime for a bottom tier safety player. But in looking at it, the same can be said about security. In a different study, we could see similar results for security. Those companies that employ top-tier security practices, they're less likely to experience a major cyber attack and 3.5 times less likely to experience downtime. However, for the bottom-tier players, they suffer the consequences. The differences between top-tier and bottom-tier downtimes to me are very interesting. Over 2,700 hours lost for a bottom-tier security player versus just 588 for a top-tier player. Though those differences really do go to the bottom line. Understanding all of that, there are some misconceptions out there regarding security. In reality, you can look at. Let me just get back to my slide there. In reality, IT is an IT, or security is an IT thing, but the real case is security is for everyone. Security lives and breathes and weighs on everyone from the C-level to engineering to maintenance to accounting. Everyone at the company should be security aware. Everyone just has to be cyber aware these days. All it takes is one lapse, and attackers can get in. When we're talking about air gaps, first off, I'm not sure air gaps exist, but even if they did, like at a nuclear facility, it's possible to jump an air gap and create an attack. The famous Stuxnet incident was a good example of that, where a USB thumb drive was used to jump in on the system and start an attack. Product certification. I'm a huge fan of product certification. But certification to me means the product is certified safe or secure the moment the manufacturer gets it. To me, how that certification remains intact is up to the end user. Is it just as safe or secure in 6 months or a year? Again, the attack costs can be staggering. Here are just a few examples of costs and how it affects victims. We're looking at small to medium-sized companies right here, and the average cost of one cyber attack can cost could be about $1.5 million. You got to learn the plan. I mean, there's one example of the Xerox case, or the Xerox study, where it said 54% of employees don't always follow their company's security policies. That's leaving any company, whether it's in their general control system or their safety system, that's leaving them at a heightened risk. Who are the targets? I mean, attacks come in all shapes and sizes, and it could be a train engineer or train engine parts maker in Pennsylvania that lost $200,000 in an attack, or for over 2 years there were attackers that were on systems of some of the bigger players out there, Exxon, Shell, that kind of thing. and they were stealing important data from the companies, and they were all victims, and they lost some incredibly important information. Here's a list of attackers, and one or more of the of all of these, one or more of the possible attackers or more prevalent attackers are the insiders, and that could be any kind of insider, accidental or some kind of disgruntled worker. And while the nation state attackers garner the most attention, as I said, the inside attack is more prevalent. They know where to go and what to do. The world of machine safety has dramatically opened up opportunities for cost reduction and increased machine uptime. There's no doubt about it. And that also means integrating safety into an integrated network. So whether you have a safety CPU or a safety PLC or any other digitally enhanced device, an integrated system is a more lucrative option for manufacturers. And we've seen that over the years. But that all means we have to keep our eye on the ball. And I just really like this quote that Peter Martin said a few years back, and to me it hits on so many different areas, but the most important of which is understand what you have and how to protect it. And also, don't get caught up in the latest and greatest technology out there, but rather, understand what you need to protect and figure out how to protect it. The standards in the industry, the manufacturing industry loves standards, and understandably so. It gives an incredible baseline to help, in many cases, protect or run a system. And one of the biggest standards is applying security to machine safety. So it's ISO TR 22100-4, which is designed to help machine builders identify and address IT security threats that can impact on safety. It complements ISO's flagship standard for machine safety, ISO 121 or 12100, which lays down the fundamentals for risk assessment, hazard analysis, and documentation requirements. And Otto Gorneman, the chair of the ISO technical committee in charge of the technical report, said machine safety and cybersecurity differ greatly when it comes to their objectives, methods, and measures. Yet, in manufacturing, they're inextricably linked. ISO TR 22100-4 will help machine manufacturers integrate the relationship between cybersecurity and machine safety. In addition to that standard, there's plenty of standards out there. There's also the IEC 62443 series of standards, and that definitely has a safety and security component involved. Best practices. As I said, understand that cybersecurity is an issue. The level of awareness from when we started our site 9 years ago to now is night and day. Cybersecurity is an issue, but as I had mentioned earlier, the Triton incident really was a wake-up call to the safety side of things. That safety is an important. Safety always has been an important factor, but securing safety is becoming even more and more dynamic. Everyone has to understand their assets and what they have out there working. I've heard stories where manufacturers have devices out on the plant floor and complete networks out on the plant floor that they're not even aware of. So you have to understand what you have out there. Create a security plan. There are plenty of people out there who keep their head buried in the sand, and they're just saying, we're such a small company, we're not going to be affected by it, or who would want to come after us? After all, we only make widgets that nobody cares about. Well, you know what? They do, and So create a security plan. Then once you create the plan, make sure all workers know about the plan. Again, the people behind the company can be the greatest asset, but also can be the weakest link. And if everybody is aware of the plan and they're quizzed on it and they're trained on it, the company is going to remain more secure. Conduct a cybersecurity risk assessment. Safety risk assessments are conducted all the time. When you're doing a cybersecurity plan, you have to do a risk assessment there because we're obviously, between the two areas, we're talking about risk. And oftentimes, cybersecurity risk assessment and the safety risk assessment work together. And then, of course, conduct vulnerability testing at all times. When people talk about safety systems and if they should be separated or integrated, I think they're missing the point here. Whether they're separated or integrated, or there's always going to be some kind of connection at some point. And when there's a connection, there is potential for a vulnerability, and there's also that potential for an opening for an attacker to get in. As I've been saying for almost 10 years, safety keeps man safe from machines, and security keeps machines safe from man. But either way, if one element goes bad, it can lead to a safety issue. And the level of connectivity, as it keeps growing, that means there's more potential, there's more likelihood of there could be an attack. So everybody has to keep aware and on top of their game when it comes to safety, because safety is not immune to the whole environment. And now, Kevin, I'm going to take it back to you.
Well, thanks, Greg. I appreciate it. Let's go to our question and answer period, and I would urge our listeners to send their questions to us now. Sean, the first question for you is for you. What are some of the most common safety hazards that you encounter in industrial environments?
Yeah, that's an interesting question. So some of those safety hazards that we see, and again, it depends on machinery. There's all types of machineries out there, from low-risk machines to high-risk machines, from low hazards to high hazards, and just as we here at Polytron, we see a lot of different machinery, and to see what we typically see a lot in hazards is where or a lack of properly guarded something is that guarding, right? So the guarding is most of the time inadequate. We like to slap a lot of safety on machines now with all the light curtains and door switches and guarding that's out there and available, but a lot of the time it's not properly done. And so when we do safety, the hazards that are there, which again, open chains to rotating machinery, rotating nip points, a lot of nip points. When guarding's put in, we get a lot of cases where guarding is not adequately done. So
good.
That's what I see the most of.
Good. And are there particular industries where you seem to find that? Is there a large variance in how different industries take matters of safety seriously, or is it more or less based on the individual instance?
And like I talked about earlier in the presentation, that culture of safety. So, these large manufacturers that have a big footprint here and elsewhere, that have more stake into, I guess, the outlook of or persona of their company. When a safety incident happens, and you can go to cybersecurity incident happened. It really takes a hit to their image. And so these large companies that typically are out there will have more of a mature culture, mature safety culture, than the required dollars to secure them in both safety and security. Where we see a trend that these lower stock, not as large, manufacturers who are, out there and pushing and trying to get as much product out as they can, as fast as they can. Safety is not on their radar, and it's hard to get them in that radar because it is an expense, and sometimes it is hard to find that ROI in safety until it hits, and then you realize, well, yeah, I should have invested in safety and security.
Well, good.
Well,
thanks, Sean.
If I can add to that, yeah, that's been an interesting issue the whole time that I've been covering safety and security, and that's, well, it's a cost, and it's not. And how do we, and what as I was mentioning earlier, safety and security can be a business enabler, but it's also got to be, that kind of message has to be either taught to the top management, or top management has to be able to filter that mentality down, because if it's applied properly, safety and security can help a business grow.
Well, thanks, Greg. Greg, as an editor and a journalist, I find trying to cover cybersecurity kind of on the challenging side. For one reason is that you mentioned already that it's typically considered by OT experts to be an IT problem. And the other is that the reporting on it is so fragmentary because people are not very anxious to report that they've had cybersecurity problems. And so you could talk about that a little bit, but I know that you go to the ARC Advisory Group Automation Conference, and that's kind of become a place for some of the smaller cybersecurity vendors to appear. And I was wondering if you could talk a little bit about how the cybersecurity supplier market is evolving or has evolved over the last 10 years as opposed to, the cybersecurity challenge.
Okay, well, thanks, Kevin. The covering cybersecurity is it can be very difficult. There's no doubt about it. Once you find out a little bit of information, then you're able to grow it and grow and really work with it. The beauty is, as it was with the Triton incident, is some of the companies are becoming a little bit more transparent, and they understand that if with transparency, actually there comes security. I mean, the industry can become more secure if you can learn from an incident. And there have been a couple incidents of late. The Triton incident. There's also another ransomware attack that where the company was hit, and they were hit hard. I mean, they were shut down, and they ended up losing, I don't know how much, it was something like $95 million. But they didn't hide it. In fact, they came clean with as much as they could about what happened. And that, to me, helps the industry. I think the industry needs to become more and more transparent about these incidents. And they could take a hit, but on the other hand, I think the people are with that awareness level of cybersecurity becoming higher and higher and higher, they can become that can help the industry become more secure. Now, in terms of more and more suppliers that are coming out there, it's amazing. Over I launched my site 9 years ago, and there were some cybersecurity suppliers out there, and they were good ones, but the level of technology and the awareness has just increased. It's through the roof, and the technology level out there is increased to the point where visibility and being able to monitor your system, you weren't able to do that 9 years ago, or it wasn't abundantly easy to do 9 years ago. But now it's you plug in a system, and then whammo, you've got you're able to know what assets you have on the floor, on the plant floor, and then you're able to monitor what's going on. You're able to monitor traffic and see, and if there is an attack happening, you're able to at least see what's happening, and then you can address it. And the amount of people that have come out, or companies that have come out, especially in the past 5 years, has been incredible. And they have some incredibly smart technology out there. But I know this is a long answer to your question, but the technology is great, but you have to have three parts to it. It's technology, it's people, and I'm forgetting the third part of it, but it's essentially you have to have standards within your organization to help apply all the technology and all the things that are going on. And people, as I said earlier, can be your strongest asset or your weakest link.
Oh, good. Thanks, Greg. Sean, in the beginning of your presentation, you talked about the need to work with suppliers, meeting regulatory standards, and providing documentation. Of that entire process, which aspect of it typically proves to be the most challenging?
The most from that, I think, getting the right documentation in that process of when I was talking about working with vendors or OEMs, the most time we spent in trying to achieve, verification process and verifying everything, we have to have that documentation. Documentation is critical, and it's required throughout the safety standards, and you'll see an ISO 12100 for risk assessments, and ISO 13849 for providing safety and validation. That documentation is required, and a lot of the time that we spent is trying to find that documentation that's first done right, is available, because without that, you're really kind of flying blind in a lot of cases. So, what I tell and work with, our manufacturers that, we always have to have a paper trail of all the stuff that we're doing. And we provide, we have our documentation, and we provide a lot of documentation with our systems and how we track everything and how we do our safety designs and validations and verifications. But when we ask for that documentation, it's sometimes hard to get. And so we request that, up front and be persistent. And sometimes we find out that a lot of people are not providing that or even doing that, and we have to, work with them to get that done, get that completed. So I hope that answered that question.
Thanks, Sean. We have time for about 2 more questions, and we have 2 additional questions from our audience, one for each of you guys. So let's do that, and we'll be ready to sign off. Sean, do you have any recommendations for a company who needs to do risk assessments but doesn't know how to get started?
Yes, I think that's a good question, and that happens a lot. How do you start? I mean, it's a kind of a big ordeal sometimes to take on a risk assessment without knowing or done it before, and there's standards that are out there, say ISO 12100 that's out there that it gives you that the risk assessment standard, gives you some flow charts. It's quite a bit of number of pages, and it can be daunting. And so just taking that risk assessment or that standard and saying I can do one is far from easy. And so again, in my position that we do risk assessments and we do those type of services, it's always good to go out and venture and find information of people that have done it or have experience or can help you provide, maybe this is your first one and you're trying to get one done and you might have many more. The way that a proper, third party or vendor should come in and help with those is as a teaching moment. When you're doing a risk assessment, you get everybody involved, you do that risk assessment, and so you can take that process and move along internally into that company, and to get those done. But also, there's a lot of folks out there and other peers that, or vendors even, that provide equipment that can help. You're buying equipment for certain types of safety components or something. You can ask their recommendations for risk assessments and how to provide risk assessments and what's best practices. So I always tend towards, and when I I guess going back to one question that, the standards will have guidelines, but they don't give you documentation or a spreadsheet or forms to use a risk assessment. So trying to create one yourself is kind of difficult, but again, there's a lot of vendors out there, integrators like ourselves at Polytron that can all do that. So do the research and always step out and find the experienced people that know how to do risk assessments to at least start that first one.
Good. Thanks, Sean. Greg, real quick, because we're running out of time, are the big automation suppliers implementing standard security elements into their products, given that every automation equipment piece can communicate with each other?
The quick answer is it's a mixed bag. There are a lot of companies that are doing it. They're getting certified for security on various products and various life cycle components, but it is a mixed bag. And what I would suggest is, in an RFP, the organization, the manufacturer, should put in that they are requiring some kind of security certification on various products.
All right. Well, thanks, Greg. That's all the time we have questions for today. I want to thank Sean and Greg, our expert panelists, as well as thank everyone in our audience for attending today's webcast. We hope it suited your purposes. For more information, go to the website link noted in the interface. I'd like to thank our sponsors for today's webcast. And now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it as we use this information to improve our webcast. On behalf of CFE Media and Technology, thanks, and we'll see you next time.